you can switch off your video. So if Mr. Shahbaz Khalid is with us.
Yes, sir. I am available. Yes, sir.
Okay, please go ahead and try to conclude in 10 minutes about role of oblique vegetation in flood mitigation. Share your screen.
Yes, sir. I am sharing, sir.
Oh no, that's your, again, this is, you are speaking from mobile.
Yes, sir. Yes, sir. I am using
So
mobile,
that's
sir.
not the way. We cannot see the whole screen. It will be very small. We can open your presentation from here and you can talk
Okay,
like
sir.
Khatija have talked.
Okay, sir. Okay.
Can you share your screen? Shahbaz Khalid
Yes, sir.
presentation. Just a minute, please. If you have shared your presentation with us, Shahbaz.
Yes, sir. I share.
Okay. Okay. When you want us to move ahead, please say next. Now we
Okay,
are
sir.
sharing your presentation. Can
Assalamu
you
alaikum,
see it
sir.
now?
Yes, sir. Yes, sir. I can see.
Okay, please go
My
ahead and
presentation. Yes.
you just say next and we will move ahead.
Okay, sir. My presentation topic is role of oblique vegetation in flood mitigation. And my name is Shahbaz Khalid, and I belong to UT Taxila. And this is the sequence of the presentation topics. Please next. Abstract, it means universally floods are known as the most destructive natural hazard, resulting in loss of lives and a huge loss of properties. The climate condition of Pakistan renders its susceptibility to different types of floods throughout the years. Structural damage due to the water-based disasters such as the flood is the main problem living in the near the flood-prone areas. The results show that the percentage increase in the house porosity decrease the hydrostatic force, contrarily increase the hydrodynamic forces. The maximum loss of energy is observed for oblique vegetation when it is at angle 30. Okay, next, sir. Introduction: flood is considered the most devastating natural as hazard during the last 3 decades. The frequency of the flood disaster loss is increased in both economic and the structural damages. There is a rising concern that climate changes is leading to an increase in magnitude and frequency. Research findings found that flood dynamic loading and the impact load caused by the wooden debris plays a vital role in the structure destruction. There is a need to propose such reforms to mitigate the dynamic effects of the floods. Many researchers have worked to find such methods to minimize flood energy using both natural and the artificial methods. The effect of oblique vegetation is not yet considered. Next, experimental setup. Open channel in hydraulic lab will be used for the experimental setup, and house made of wood will be was used for different with different porosities, and the actual discharge will be measured using the rectangular channels, and the vegetation of varying density on upstream side of the house and the head of the water at different location will be measured with the point gauge. Next, sir. This is the schematic diagram of experimental setup and showing the flow conditions and the vegetation condition and the house model. Next, sir. These are the initial conditions and the initial flow numbers, vegetation density, vegetation thickness, and the vegetation length, vegetation types, building distance. Next, sir. Results and discussion. And first we find the hydrostatic force, and the graph is showing the effects of hydrostatic force due to the oblique vegetation having the same porosity. And this figure shows the result of experimentally determined values of hydrostatic force. It represents that for any oblique vegetation, hydrostatic force is linearly decreased with the linear increase in the porosity. The hydrostatic force depends on the water level at the upstream side of the house. So as we increase the porosity, more water passes through the house and the upstream water level decreases as compared to the solid wall. It also represents that for each porosity of the house, hydrostatic force is minimum for vegetation angle 30. And experimental results revealed that by changing the angle of vegetation from 0 to 30, water level downstream of the house is increased and hydrostatic force decreases. When the vegetation angle is changed from 30 to 45, water level at the downstream wall of the house decreased and the hydrostatic force increases. Next. And second one is the hydrodynamic force. It explains the behavior of oblique vegetation against the house model of varying porosity. For each vegetation angle, hydrodynamic force is linearly increased by increasing the house porosity. It also represents that for the same porosity of the house, hydrodynamic force change as the orientation of the vegetation is changed from 0 to 30. Hydrostatic force increase and as the orientation is changed from 30 to 45 degree, hydrodynamic force decreases. Hydrodynamic force is maximum for the vegetation angle 30. From this diagram, it is explained. Next one. And third one is the energy dissipation. It represents the percentage of relative energy loss for different angles of vegetation for different porosity of the house. For each angle of vegetation, by increasing the porosity of the house, percentage loss of relative energy is increased. Percentage loss of energy is maximum for the house porosity of 20%. And by increasing the porosity, the upstream water level is decreased, so the percentage loss of energy is increased. It also represents that for each porosity of the house, the percentage loss of energy is increased as we increase the angle from 0 to 30. The a little decrease in the energy loss is observed by increasing the angle of vegetation from 30 to 45 degree. Next. Water surface profiles against each angle of vegetation was observed. From the figure represent the water surface profiles of vegetation angles for different angles. It was observed that the effects of hydraulic jump generated by the vegetation was nullified by the backwater rise of the house model. The hydraulic jump was observed on the upstream side of the house model. A large jump was observed in case of non-porous house model, while a shorter jump was observed in the highly porous case. Backwater rise was highest in the non-porous case. Next. These are the diagrams for the water surface profiles for different angles of vegetation. Next. Conclusions. Evaluating the flood in induced risk, structure stability is the main concern in flood-prone areas. Structure designed without considering the dynamic load are badly affected by the flood dynamics. Experimental results conclude that by a maximum energy is dissipated in case of vegetation angle 30. Moreover, as the porosity of the house is increased, energy dissipation is also increased. This will help in design the porous house in flood-prone areas. Next, and these are the references. Thank you.
Thank you very much, Mr. Shahbaz Khalid, for your presentation about thanks to Shahbaz Khalid for nice presentation about the effect of the vegetation angle and the porosity of the house. I think you are talking about the house density and angle of the vegetation, these two things you were talking about.